All right, let's jump right in. So, in our digital world, data is always on the move, right? It's not just sitting in one spot anymore. It's zipping between different cloud providers, think Amazon, Google, Microsoft, you name it. But how do we actually keep all that information safe while it's in transit? That is the big question we're digging into today.
So here's the game plan. First, we'll look at why pretty much everyone is using multiple clouds these days. Then, we'll uncover the hidden dangers that come with that. After that, we're going to introduce a new kind of protector called Atlas, peek under the hood to see how it thinks, see how it stacks up against the competition with some real data, and then, finally, we'll talk about what this all means for the future of security.
All right, first up, the multi-cloud revolution. You know, the days of just putting all your digital eggs in one basket? Yeah, those are pretty much over. Today, it is all about being flexible and having options. And look, this isn't just some fad for a couple of big tech companies. The research is clear. Most organizations are now spreading their apps and their data across a bunch of different clouds. And why are they doing this? Well, it's to get the best tools from each provider and, maybe more importantly, to avoid getting trapped with just one company. And this whole new freedom is powered by a really brilliant piece of tech.
It's called containerization. And if you've ever heard people talking about Docker or Kubernetes, this is exactly what they do. They basically wrap up an application and all its dependencies into this neat, tidy little package, a container that can run the same way no matter which cloud you put it on. The best analogy? They're like the universal shipping containers of the digital world.
Okay, but all this flexibility, it comes with a pretty serious catch. Moving these containers from one place to another isn't nearly as safe as it sounds. It's a journey that's actually filled with risk.
I mean, just think about it for a second. What actually happens when one of these digital containers moves from, say, an Amazon data center over to a Google one? See, each cloud provider has its own security, its own rules, kind of like its own port authority. And that little gap, that moment of transfer between them, is exactly where things get dangerous.
And this slide really nails the heart of the problem. For years, our security has been static. You know, like a simple padlock with a key that never changes. But the threats we're up against today, they're dynamic. They're smart. They evolve. They learn. A simple padlock just has no chance against a lockpicker that gets smarter with every attempt. So here's the bottom line. During that move between clouds, containers are wide open to all kinds of trouble. Data can be intercepted. Someone unauthorized could get access. It could even be tampered with. And what makes it even worse is that each cloud is kind of living in its own little security bubble. There's no shared intelligence. So if one provider learns about a new threat, the others are completely in the dark. And this is where things get really interesting. See, to fight a threat that learns and adapts, you need a defense that can do the same thing. You need a smarter guardian. And that's where Atlas comes into the picture.
So Atlas stands for Adaptive Threat Learning Algorithm for Security. And as the research paper lays it out, it's a whole new framework built from the ground up specifically to protect those containers as they jump between clouds. This isn't just another padlock, it's an intelligent security system.
So, what makes Atlas so special? Well, a few key things. First, it pops those security bubbles by creating collaborative threat intelligence. Second, it uses what's called adaptive encryption, which can change its strength on the fly. Third, it's context-aware. It's actually looking at the container it's protecting. And finally, it's smart enough to find that perfect sweet spot between maximum security and minimum slowdown.
Okay, so how on earth does it do all of that? Let's pop the hood and unpack this secret sauce to see how Atlas actually thinks.
Now, the technical workflow in the paper is pretty dense, but you can really boil it down to these 4 main steps. First, all the different cloud providers share threat intel, securely, of course. Second, Atlas looks at the specific container being moved and the network conditions, all in real time. Third, based on all that info, it dials in the perfect level of encryption. And finally, the container makes its journey, wrapped in this custom-made shield of protection.
That first step, the whole sharing intel thing, that's powered by a technique called federated learning. And honestly, this is just genius. It lets Atlas learn from attacks happening across all the clouds. But, and this is the amazing part, without any of them ever having to share their sensitive raw customer data with each other. It's the ultimate win-win. You get collective intelligence with total privacy.
And that third step is just as cool. Instead of a simple on or off switch for encryption, think of Atlas as having a dynamic security dial. If it's moving a super sensitive container over a network that seems a little sketchy, it cranks that dial all the way up to maximum. But if it's low-risk data on a trusted line, it dials it back to keep things moving fast. It's always the right amount of security at exactly the right time.
Now, all of that sounds amazing on paper, right? But how does it actually perform when the rubber meets the road? Let's throw Atlas into the arena and check out the hard data from the study.
Let's start with the absolute toughest test there is, zero-day attacks. These are brand new threats, the kind nobody has ever seen before. And against these, Atlas scored an incredible 97.8% detection accuracy. That, right there, shows you the power of a system that learns. And when you zoom out and look at its average accuracy across all kinds of attacks, it's the same story. Atlas hits 98.3%, which just blows past other leading security frameworks that were used as benchmarks in the research, like Cunivria and Replica Watcher. I mean, it's not even a close race.
But here's the real kicker. It's not just more accurate, it's also way more efficient. This table shows us that Atlas encrypts data more than twice as fast as the competition, it uses less of the computer's brain power to do it, and when things get really busy, it raises far, far fewer false alarms. So it's not just stronger, it's faster and smarter too.
So what's the big takeaway here? What does this all mean? Well, this goes way beyond just protecting company data. This points to a massive shift in how we have to think about security in a world that's getting more connected by the second.
And the authors of the paper really said it best. Atlas isn't just one single tool, it's more like a blueprint for the future. It lays the foundation for a whole new way of thinking about security, a way that's adaptive and intelligent.
And that leaves us with one final, really important question to think about. In a world where everything from our cars to our coffee makers is connected to the internet and constantly changing, are those old static defenses completely obsolete? Is intelligent, adaptive security like Atlas no longer just a nice-to-have, but the only kind of security that actually matters anymore?